Hello, in this video we'll try to learn how to sketch a rational function from start to end in a step-by-step manner, right? So let us first see our example, right? So let's say I have a rational function of x equals x plus 1 over x minus 2 and x plus 3. So this is my rational function I'm going to try to sketch. All right, so and of course I'm going to divide my screen into two halves, and I'm going to, on the left hand side, I'm going to write down each step one by one, and simultaneously I'm going to try to solve this particular problem. Okay, so number one step is we need to find the x and y intercept. Okay, so let us see x intercept. To find x intercept, you know that we need to do what? Put y equal to 0. So y, which is equals function of x, equals 0. So let's do step number one for this particular problem. So x intercept, so I am putting y equal to 0, which is function of x, and then on the right hand side I have x plus 1 and then x minus 2 multiplied by x plus 3. Okay, so from this I can actually write x plus 1 is equal to 0, so x is equal to -1. So this is my x intercept of my particular for this function. So what is the intercept? So at x equal to -1. Now let us see how I can find the y intercept. So this is the next step. To find y intercept, as you remember, we need to put x equal to 0 in the equation. So if I want to find y intercept, so let's put, so I want to find y, which is function of x, and in this case I'm going to put x equal to 0. So now let's see, in the numerator I have x plus 1, so as x equal to 0, so it will be 0 plus 1, and then on the denominator I have x minus 2, so it will be 0 minus 2 multiplied by x plus 3, so x is 0, so it is 0 plus 3. So what I am getting here is I am getting that my y, which is equal to function of 0, is what? The numerator it is 1, on the denominator is -2 multiplied by +3, so it is -6. Okay, so this is my y intercept. All right, so I already found x intercept, I already found y intercept. Okay, so now let us look at the second step. Okay, so step number 2 is we need to find the vertical asymptote. Okay, so vertical asymptote. And just to remind you, to find the vertical asymptote, we did in the previous videos. To find vertical asymptote, we basically did what? We equate the denominator equal to 0, and we found the solution. Okay, so in this case also, so we need to do what? We need to equate the denominator dx equal to 0. So let's see my step number 2. What I want to and in this case, what is my denominator? My denominator is this whole thing. All right, so I am going to equate what? X minus 2 multiplied by x plus 3 equal to 0. So what I get x minus 2 equal to 0, and I can say x plus 3 equal to 0. So I get x equal to 2. This is my one vertical asymptote, and I get x equal to negative 3. So this is my vertical asymptote. All right, so we get vertical asymptote. Okay, so now step number, so this is what a vertical asymptote, just to remind you, vertical asymptote. Now let's look at step number 3. So step number 3 is find horizontal asymptote. Horizontal asymptote. Now I want to remind you about horizontal asymptote from my previous video. So as you can see, we solve this particular problem, and for horizontal asymptote we know that we need to compare if it is n is greater than m, sorry, n is less than m, or n is greater than n, or n is equal to m. And what is the definition of n? N is the highest power of the numerator, and what is m? M is the highest power of the denominator. All right, so let's look at for our particular problem here. So step number 3, in this case, what is my highest power of my numerator? Highest power of my numerator is 1. So my n is equal to 1. Okay, so that is pretty clear. Now let us see my m. Okay, now look at my denominator. I have x and multiplied by another x here. So what I'm going to get? Actually I am going to get x square. Okay, so x square means what? My highest power of my denominator is 2, so my m is equal to 2. So in this case my n is less than m. So if n is less than m, if n is less than m, then what? X axis is my horizontal asymptote. So I can write what? That x axis is the horizontal asymptote. Horizontal asymptote. Okay, now before I jump into step number 4, what I want to do, I want to assimilate or plot whatever information I have learned up until this point. Okay, so let's do it. So what I'm going to do is I'm going to try to plot it over here. Okay, so this is my x and y axis. So in red color I'm going to first try to put my vertical asymptote at x equal to 2 and another vertical asymptote at x equal to negative 3. So at this is my x equal 2. So this is my one vertical asymptote at x equals 2. Okay, now I want to plot the other vertical asymptote at x equals negative 3. So this is my another vertical asymptote at x equals negative 3. All right, so we are done with vertical asymptote. Okay, now I am going to try to plot the horizontal asymptote. So horizontal asymptote, which is my horizontal asymptote? X-axis. So I am going to use actually the yellow color for plotting the horizontal asymptote. So as you can see, so this is my x-axis in yellow color, and this now my what? Horizontal asymptote. So my horizontal asymptote is in yellow color. Okay, so we already plotted horizontal asymptote and vertical asymptote, so we are done. So this is, so just to clear up horizontal asymptote. Horizontal asymptote. All right, Now let's plot x-intercept and y-intercept. Okay, so I am going to use some other color for that. So what is my x-intercept? My x-intercept is at x equal to -1. So x equal to -1 is let's say somewhere here. Okay, so here is my -1. And what is my y-intercept? Y-intercept is x equals -1/6. Okay, so -1/6 is let's say somewhere here. Okay, so it is what, -1/6. So we already plot x-intercept and y-intercept. So so we are done with plotting whatever information I have up until step number 3. Now again, before going to step number 4, now I want to basically try to plot, not exactly, rather with the knowledge I have from the information we have here, approximately. All right, so we are not going to claim that the plotting we are going to do is 100% correct, rather we are going to claim that that is basically a approximate, and later we are going to confirm it using our step number 4. Now let's see, I have x-intercept here, I have y-intercept here. So of course my graph is going to connect these 2 points. Okay, my graph is going to connect these 2 points. Okay, that is for sure. Now from here, how I can go? Okay, let us see. This is one way of going. Now can I go this way? I cannot, because why? I am getting another x-intercept. I cannot have another x-intercept. As you know, this is the only x-intercept, so this is not possible. Now what about this way? I cannot go because my graph cannot cross the vertical asymptote. Okay, so this is also I cannot do. Also I cannot go this way because my graph again intersected at y-axis, and which I cannot, because I cannot have more than y-intercept. So this is also not possible. So as you can see, the only possibility is basically for my graph to be asymptote about this vertical asymptote. Now similarly on this side also, as you can see, I cannot go this way because I cannot cross it. Also I cannot go this way because I cannot cross x-axis, and of course I cannot cross the vertical asymptote here. So the only way is that asymptote about this vertical asymptote. So so this is the middle portion, of course. Okay, now let us see for this vertical asymptote, horizontal asymptote, and top, bottom, and this side. Okay, now in the dotted line, using dotted line, I'm going to try to plot some scenario. Again, I'm not claiming these are correct, I'm just saying just possibility. As you know, I have a vertical asymptote here, I have a horizontal asymptote here. So if there is a graph in this zone, it is basically, it can be something like that. So I am following the vertical asymptote, also the horizontal asymptote. Of course I can have what on the bottom, I can have that's the possibility. Okay, so on the right hand side of my this vertical asymptote, I can have 2 possibility. Okay, what is the one possibility? One possibility is either this graph or either this graph. Okay, we are going to confirm which graph is the possibility. And then on the left hand side of my this vertical asymptote, I can have again 2 possibilities. So what are my 2 possibilities? One possibility is that the graph will be at the top, and another possibility is the graph is going to be below x-axis. Okay, so we do not know which one. We are going to confirm it using our step number 3. So let us look at step number 4. So let us look at step number 4. So in the step number 4, we are going to use a test point method. Okay, so let's start using test point. So if I want to use test point method, I need to first see my different zones. So what are my zone? So my first zone is a negative infinite to negative 3, and the second zone is what? Negative 3 to negative 1. So this is negative 3 to negative 1, that's the second zone. What is the third zone? Negative 1 to positive 2, so this is negative 1 to positive 2, so that's the zone. And the fourth zone is what? 2 to positive infinite, so it is 2 to positive infinite. Okay, so these are my 4 zone. Okay, so let me write down this 4 zone here. So what are my zone? So my zones are negative infinite to negative 3, and then negative 3 to negative 1, and then negative 1 to positive 2, and positive 2 to positive infinite. Okay, so now let's choose some test point. All right, so so let me use another color. So from this first zone, I'm going to choose a test point, let's say at x equal to negative 4. Okay, at x equal to negative 4. So this is at x equal to negative 4. Okay, from the second zone, I'm going to choose a point at x equal to negative 2. So at x equal negative 2. And then from the second zone, I'm going to choose a point at x equal to 0. So at x equal to 0. And for the fourth one, I'm going to choose a point at x equal to 3. So at x equal to 3. So these are my 4 zone. Okay, so now I am going to try to find what? The sine of my function. Okay, so I'm going to try to find the sine of what was my function, which is x plus 1 over x minus 2 over x plus 3. All right, so this is the sine I want to find expression. All right, so let's start with x equal, if x equal to negative 4, so what happened? So in this case, this x will be negative 4. So negative 4 plus 1, it is going to be what? Negative 4 plus 1. So let me write it down. Negative 4 plus 1. On the denominator, it is what? Again negative 4, negative 2, and then I have what? Negative 4, positive 3. Okay, so let's see what is the equal. I don't care about actually the actual numerical value, I care only the sign. So let's see, negative 4 positive 1 is what? It is going to be negative on the numerator. Okay, let's see, negative 4 negative 2 is negative 6. So it is negative for the first term of the denominator multiplied by negative 4 positive 3. So this is also a negative 1. So it is also negative. So if I have 3 negative, so ultimately my sign is negative. So what is the sign for this case? Negative in this zone. So negative means my graph must need to be what? Below x-axis. So what is the below x-axis, guys? Then my graph will be basically this one. So this is going to be my plot of my graph. So that means what? That means top one is not a possibility. So I am going to now erase the top graph. So this graph is not a possibility. All right, so that's good. Now let's look at the second one. Okay, second zone, x equals to negative 2. So when x equals -2, what happened? -2 plus 1 is what? It is negative sign. Then -2 is -4, so it is negative. And then -2 +3, so it is what? Positive. So if I have two negative sign, it is going to be positive. So on this zone I am going to have positive, so that means my graph need to be above x6, which it is already. All right, now let us see for x equal to 0. Now I just wanted to remind you, when x equal to 0, my function of 0 is what? -1/6, so it is negative, so I don't have to do anything. I already know the sign is negative, so that means in this zone my graph must need to be below x-axis, which is already is in the below x-axis already. Now let's look at the last one. When, let me use another color then. When x equal to 3, what happened? I have the numerator x, so 3 plus 1, so it is positive on the numerator, and then 3 minus 1, which is also positive, multiplied by x equal to 3, so 3 plus 3 is 6, also positive. So I have 3 positive, so ultimately it is positive. So that means what? In this zone it is positive, so that means my graph need to be above x-axis. So if my graph need to be above x-axis, then what is going to be my actual graph? So my actual graph will be this one. So my actual graph will be this one. So that means what? That means the graph below is not going to be the plot. So let me erase this portion of the graph. So this is basically the final plot of my the function. Okay, so that is actually the end of this example. I hope you understand. So all the best.